Hello, this is Eric Colburn from ericcolburn.com and Colburn Strategic Partners. And today I'm really excited to be talking to you about a revolutionary new software program out there called DatuGram 3D by a company called DataMate. And what this does is allow you to take survey measurements and drawing from regular consumer grade camera images and bring them into the software, and I'll show that to you in a minute. The process though is this: you take that consumer grade camera. They can be easily purchased for under $500. We do recommend an 18 to 20 megapixel camera because that will allow you to get 1 to 2 centimeter accuracies at, let's say, 400 feet or that range. Again, that depends on the angles between the images and your survey control and factors like that. But you just go out in the field, you take a minimum of 3 images of what you would like to measure. We do recommend doing more than that because each image adds redundancy to the calculations and helps the automation process of finding new points in the software. You do have to do a certain amount of surveying, conventional surveying, to locate anchor points for control to anchor the images, and I'll go over that in a minute, and that's about to change in new releases fairly soon. And then you come into the office and you're looking at DatuGram 3D right now. You upload your images. There are 14 images that I already uploaded, and you do have to match those images to the camera used in the field. There's a one-time camera calibration done. Very simple process. You do that using the software under Tools, Calibrate. I'm not going to go through that process, but you run, in this video, I'll do that in a separate video. You run the calibration wizard. You print out a checkerboard designed sheet that you mount to something flat like a board, and it just walks you through taking a minimum of 3 images of that checkerboard design, holding the camera at different angles. It's a very simple in-office technique that you use. It will not take you more than 5 minutes to calibrate your camera. So you select the correct camera for the images that were taken. Now we move to the next screen, which is the control point screen. And what you can see here are the yellow point markers, which show how this one image was anchored. I'll turn on the point names there so you can see the numbers for them. And at this point in time, DatuGram 3D, this is version 2.5, requires that you have 4 control points per image. They don't have to be unique control points in each image. They can be the same control points, but each image right now, to be georeferenced, has to have 4 control points. Within the next few weeks, there'll be a new release of DatuGram 3D that does not require nearly as much control points. Matter of fact, you don't need control points on every image, and it really automates the process of anchoring the images a lot better, and you require even less field work, so that's always a good thing. But right now, let me just show you how this works. We import a control file. Over on the left, there's already one in place, and that's just a simple point northing easting elevation file in this case. And then we zoom in. Let's say we wanted to use this corner of this road striping for an anchoring point. We click on that point where we feel it is in the field, and from the drop down list we match up that image location to an actual point number, which I don't have one here. I'm just using this as an example. So it's a very simple process of identifying them. And then once we've anchored the images, what we have to do is run a quality check. And it's going to process the images and compare them to the surveyed control. In this case, again, throughout the process in DatuGram 3D, you'll notice we use a warning system of red light, yellow light, green light. And this comes up with a green light, meaning that in comparing the image locations to the surveyed locations, it was within residuals of less than 2 pixels, which is very good. And we can move on to the next step. But let's just say, and these are more survey 101 issues, let's just say, for instance, when we anchored point number 90, it was really point number 89. Or instead of picking the correct location here, we picked the wrong crosswalk stripe completely. Or we brought in the wrong point control file to begin with, and that certainly happens. If you run the quality check, you are likely to get a red warning sign saying that there are major blunders and you actually cannot move on to the next steps. Or if you were just, your survey control maybe has some problems in it, or you were a little sloppy in picking the points on the images, maybe you picked the middle of the parking stripe for point number 90 or the wrong corner, let's say, and you run the quality check, it's likely to come up with some yellows built into the system. And you could move on to the next step, but you really should address those issues first. And once you have everything so that it comes up green, we can click the next button. It's now, in this case, going to calculate new points that were already drawn before. This is a real project that was worked on before. But more importantly, it's going to calculate the residuals and georeference all the locations of the images and the camera locations. And that's something different about this system, is we don't need to know where the camera is located. It sort of reverse engineers that. And that gives you a lot of freedom to take the images where it's convenient for you to do so. And so what we're looking at here is the new point screen. And what we can do over on the right hand side is we can select a layer to start drawing on. We can create those on the fly. And then there's a toolbar here that we can move around, but we can create new points. The next option is polylines, or, which I'm going to show you right now, a polygon. So I select that as my drawing option. And then let's just say I zoom in and start drawing this crosswalk stripe. Give it a name. And I'm going to go slow here, but there's really no need to double click by accident there. You'll notice on the upper right hand side that as I'm clicking along, the software is automatically trying to find those same locations in other images. And when it's found the clicked point in at least 2 other images, it now calculates a full 3D value for the points, and they turn green. And technically we only need 2 images to do that, but the third image, which DatuGram 3D requires, adds to the redundancy and the accuracy because of that. So I'm just going to finish drawing that crosswalk stripe, and then I'm going to find it over here in the objects. There we go, and highlight it. And now you'll see all 4 vertices have turned green, meaning that it's extracted automatically by finding the same pixel locations in other images. It extracted full 3D values for those vertices. And we'll look at the accuracies of those in a minute. But first, what I want to show you is I want to switch to another image completely from the other side. And you'll see correctly located and projected onto this other image is what we just drew. So the power of that is really we can draw on whatever image we want, and likely you'll pick the images that have the best location for you to draw for the objects that you want to draw. So there's a lot of flexibility there. Now let's go back to the first image. And it's a little busy with some of the drawing that's already been done on here, but let me edit, select all for the control points that we used, and then project them onto the image. So this was a real project where they went out and they located as much as they could for an hour or 2. And some survey companies are using this. You'll see these little arrows are what was actually shot in the field using conventional methods. So they use the images for quality control purposes, which is very interesting and neat to do. But likely what will happen is the first time you do a project in DatuGram 3D, right, you'll do it conventionally and with DatuGram 3D. And this way you can project the points onto the images, and when you feel comfortable, and you can snap to them too in the drawing process, and when you feel comfortable with the results you're getting, the next job you'll probably use half as many conventional surveying control points, and the next job half as many again. And certainly there might also be instances, for instance, you can see there's a little wooded area over on the side here that you might just have to do some conventional surveying in because it's not going to be conducive for using imagery to do the drafting and measuring on. So I'm going to turn off those projections for a minute and the names, make it a little less busy. So one of the things you will notice here is that these images, and I'm sure you have noticed, is these images were taken from the air. Height definitely helps this process because it, at least if it doesn't completely eliminate, it reduces the problem of foreground obstructions, whether that be vehicles, maybe in this case, and bushes and things like that. And this was done, project was done using a small UAV and just, again, a regular consumer grade camera. 5 minutes in the air, they had all the images that they needed. And but certainly the way you could do this too is with a telescoping pole. If you could get the pole up about 25, 30 feet, you could easily do this. It's not to say that you can't do it by taking pictures from the ground. You can, although maybe that technique is a little more suitable for building facades because you're looking straight onto the building facade. But a little bit of height helps. We definitely do recommend using either a monopole or, where appropriately, a UAV. So a couple of things about this is that DatuGram 3D lets you do things faster because A, you're doing less field work, and B, the drafting in the office is sort of what you see is what you draft. It's very easy. It's not like looking at field notes and trying to determine how to connect the points. Once you project the points, if you have them onto the images, you can tell how they connect. Or, simply you're just identifying objects like tops of curbs, islands, poles, stripes, things like that. It's very clear what you're drafting because you're looking at it. The other benefit to DatuGram 3D is safety. So here's a case of a road. This is a real project where they would have had to get a police detail to go out work in the road. So cost too, right, is an issue. And they would have had to work at night is an issue. But in my point of view, it's the cost, while important, is not really the issue here, right? It's safety. If you don't have to go out in the road to take some measurements, you know as well as I that you try not to go out on the road to take measurements. It's dangerous. So there's a safety feature to DatuGram 3D in addition to being able to do things faster and less costly. So let's say we've gone through the images and we've drawn everything we want to draw. We can go to the next screen, which is the approve screen. And we do feel that surveyors should be actively involved in approving what they draw. And what this does is it tiles all the images that the points are found in. So for instance, the fourth vertice of the, I keep wanting to say parking, but the crosswalk stripe that I drew, which is highlighted right now, this first image is the point I picked in that image. And then these other images or tiles show where the software, through the automation process, calculated the same point to be. And what you can see here is that in all these cases of what we drew, where less than 200ths or less, the worst case is in elevation is 200ths in accuracy, which is, I guess, is one that's 21,000. So we're talking about 200ths or better accuracy, which is not too shabby. But if, for instance, you wanted to go in and you wanted to tighten that up, you can just go in and click in an image and make things more accurate. But you'll also see at some point, and again, I wasn't super careful about where I selected the parking stripe. Normally you would, obviously maybe you don't care about a parking stripe, how accurate it is, but if there's something you want accurately, normally you would zoom in a lot further than what I was doing for demonstration purposes and select it. But what's neat about this is you can refine your accuracy just by going through additional images. And what happens is, even if it's located accurately to begin with in the software. It stops after a certain number of images because it knows it just doesn't need to go any further. But we can continue on, and this is a good example where we can actually add that point manually to all the images that point shows up in, and there wasn't too much accuracy to improve on, but we went from about 200ths to about 100th.5. So you can do that if you're not happy with the results, and we do recommend that you go through and review your new points to make sure that they're at an accuracy level that you would approve of. No pun intended, I guess. But so the next step is the reports page, and what you can see at the top is a report for your control points. In this case, the residuals in X, Y, and the elevation is 100th or less when compared to the coordinate values of what you surveyed in the field to what was calculated using the images. And we have the new point here, which is what we've drawn. Okay. And what's interesting about this is I think it's the first time that, using topographic mapping, that you could actually quantify and report what are the accuracies of the measured points. Now, we could have estimated conventionally based on the errors for each survey control point and the estimated error for the angle and distance to that topographic point. But typically, right, you only take one angle and one distance. So you really don't have any redundancy built into it. With this system, because it's locating those points in at least 3 images and often more, we have a high level of redundancy in multiple measurements to calculate what the accuracy of each individual point is. And you've never really been able to do that before. The other point that I'd like to make is that unlike GPS or maybe conventional aerial photogrammetry, there is no degradation in the elevation accuracy. So you have the same accuracies X, Y, and Z. So in this case, we're talking, again, using an 18 to 20 megapixel camera, some proper techniques in taking the images and using and measuring with your survey control and having high accuracy survey control to begin with, you can obtain 1 to 2 centimeter accuracies up to, like I say, about 400 feet with an 18 to 20 megapixel camera. So that's pretty awesome, really. So let's go back to the report screen. And what we can do is we can do essentially no projection in that. It's like looking straight down on the project, which I'm going to do in a minute. Or we can project to a horizontal or vertical plane. So if you were doing a building facade, let's say, we might want to project all the points to the face of the building. So we can select 2 points on that plane, and then all the other points get, adjusted as if they were based off of that plane. And really, it doesn't change the coordinate values of any of this. It just changes the way the labels show up and maybe makes it a little easier once you export it to CAD to work with. And speaking of which, we can export point files, XYZ or YXZ, or we can export a DXF file to your favorite CAD program, which I'm going to do right now. I'm going to overwrite this one that I use all the time. And let's just open that up, that DXF file. Which I don't know. There we go. I don't know why that's the video capture program, I think, was taking up some resources there. So we've opened up the DXF file. You can actually see this is the parking stripe I keep calling it a pocket stripe, the crosswalk stripe that we drew on the image. And let's just orbit this and show you that it is full 3D. You can, not much elevation change in the intersection, but you can see the elevation change in the intersection. But certainly you can see that in addition to drawing features on the ground, they had drawn in this beforehand also a building facade. So you can see that this is indeed a full 3D model that has been drawn using only images and a little bit of survey control. So I think that's pretty awesome that you can do that. But with that said, that in addition to a release coming out shortly that allows less control points, version 3.0 of DatuGram 3D will be out very shortly, within a few days, and that allows real-time integration to AutoCAD, so that once you link a drawing to a DatuGram 3D project or job, whatever you draw in DatuGram 3D will automatically be drawn in the linked AutoCAD file. Alternatively, it works backwards too. So if you opened up, let's say, an older drawing in this coordinate system and you linked it to this project, you would be able to project that AutoCAD drawing onto the images. And that could come in handy for a lot of reasons, certainly to maybe see where design features fall on the face of the earth. But let's just say we were updating an as-built plan, and when we project the old drawing, maybe it's the design drawing, and we project it onto the images, new images, maybe we discover that there's a whole new island there, okay? And so it's very easy at that point just to visually identify what needs to be updated and go in and draw that right in DatuGram 3D, and it will automatically update in AutoCAD. So that's a pretty exciting feature right there that, again, I think comes out in just a couple of days. And that's why I wanted to show you this version first, because I think you're going to be blown away. As cool as this version is, you'll be blown away by version 3.0 of DatuGram 3D. Additionally, and this is a question we get all the time, additionally, about mid-year, there will be another release that will have a couple of new features. A new feature within the software called Topo Points. There'll be an additional button on the toolbar here. And let's say we wanted, right now this is geared towards mapping out features that we can see. But let's say we wanted to do topographic mapping, and let's just pretend for a minute that in the middle of this intersection is a stockpile of dirt. So we would we will select the Topo Points button. We will draw a polygon around the area just to limit the calculations, and DatuGram 3D will then automatically extract a 3D surface of that area. So that can be great for calculating stockpiles. And again, that's a safety issue. I'm a surveyor myself. I was not aware. I was told that OSHA does not let surveyors go on top of stockpiles anymore to take measurements. So surveyors are using a variety of different techniques, including laser scanning, to calculate the 3D surfaces. We can do that, I think, a lot more easily just using conventional camera and DatuGram 3D. Also mid-year, for those on the subscription service and upgrade plan, there'll be a tablet application that the field crew can go out, and once they take the images, it will automatically synchronize those images with the tablet. Again, most new cameras are Wi-Fi enabled, and that's something, if you're getting a new camera, please contact me. My information will be at the end of this video shortly, and we can give you some recommendations. We don't care what camera you use. We're fairly camera agnostic, but it is important maybe to have that feature that it's Wi-Fi enabled for a couple of reasons. If you were using it on a telescoping pole, you can download an app on your smartphone and control that camera remotely through Wi-Fi, in addition to working with the tablet application that'll be coming out mid-year. But the field crew will then be able to look at those images on the tablet and mark right on the images what the control points were, both for location and point number. And that really helps the workflow go better. But additionally, and this is really cool, is the data, the images, your survey file of the control points you located will all get uploaded through the cloud to your office. Somebody at the office can look at this project real time, make recommendations, maybe say, hey, you know what, Bill or Sue, out there, could you locate the corner of this parking stripe would make an excellent anchoring point. And then the field crew will also be able to do some sketching right on the images so that the office people can understand how the line work should connect. And again, the beauty of that system is that the field crew does their work in the field. It gets verified by once it's uploaded through the cloud. But then all that information is back at the office immediately so that somebody at the office can start working on this job while the field crew goes and moves on to another job. So really will help you be much more efficient working in the field and the office, but particularly working in the field and the office using DatuGram 3D for field to plan techniques. So I hope you really enjoyed this demonstration. I really think this is something that you will learn how to use within your business in a lot of different ways. And what I will be doing in the next few weeks is showing you, and hopefully with the new version out in a couple of days, but showing you some real life case studies on how DatuGram 3D is being used by surveyors around the world, and different ways that you can work faster, less expensively, more safely. I think that's very important. There are a couple of examples where safety is a really key feature here, and more accurately too, because you can now take your topographic mapping to new levels of accuracy using only a regular consumer grade camera. I know I've said that a few times, but really it's amazing the quality of the cameras that are out there now that are very inexpensive. And again, a little bit of surveying control. We're not taking surveyors out of the picture here. You do need some surveying control to anchor the images. So again, there'll be some contact information coming up on the video shortly. I do hope that you will reach out to me and contact me if you have any questions. If you'd like to schedule a short webcast, I can show you how the software works in a little bit more detail, or show you other examples of work that might be similar to how you are using it in your surveying business rather. And that's something that I really look forward to working with you to figure out how to implement it in your business. And so please do contact me. I can be reached by email at eric@colburnstrategic.com, or you can call me on my 800 number, which is 1-800-277-3265, extension 700. But again, all that information will be here. There's information about Datamate at datamate.com. You can also visit ericcolburn.com, where there is information on DatuGram 3D. And I look forward to hearing from you. I really want to show you how this can revolutionize your surveying works by using DatuGram 3D. Thank you. Work smart and be brilliant.